All right, let's go over your day two assignment on your normal model basics. And so here, first, you had the vehicles, and we were interested in the miles per gallons that they get. Okay, and so we knew that that was normally distributed. And so if you had filled this out, then you would have it looking like this, where we had the mean was 24.8 and the standard deviation was that 6.2. So I added up 6.2 each time and then subtracted down 6.2. Make sure you are labeling what the context of this problem is. And then I put the percentages in each section. So now I can answer my questions. So between or the middle 68%, well, that's one standard deviation down, 18.6, up to one standard deviation up of 31. Get more than 31. So that's the section above 31, and that's going to be the 13.5 plus the 2.35 plus the 0.15. And so that's how you get your 16% above one standard deviation. Well, here between 31 and 37 is that middle, that's it should, I think it says 37.2 on yours. So between 31 and 37.2, that's just this little section of 13 and a half. And the worst 2.5%. Well, that's this part that is below, because 2.35 plus 0.15 is 2.5%. The part below two standard deviations down. So that's 12.4 miles per gallon or less. All right, and let's see what we got here. Okay, so now here's one of those ones where they're telling me 68% of the data is between 51 and 64. So that is what's telling me that 51 and 64 are one standard deviation below and above. So to find that middle, I added and divided by 2, so that averages 57 and a half. And then I know that 57 and a half to 51 is one standard deviation down. You could go, you could go up to the next one, whichever. And so that's a standard deviation of 6.5. All right. Next, we had the same idea, but we had with 95%. So that's telling me that is two standard deviations wide from 62 kilograms to 90 kilograms. And so then I average it to find the middle. And then 62 is two standard deviations down. So 76 minus 62 is 14. So this distance of 14 is two standard deviations wide. So that's why I divided by 2 to get 7. Next, we had another one where you are asked to draw out and label the male shoe sizes with an average of 10 and a standard deviation of 1.5. Label the context. Make sure you have put that in there and you label those percentages. So then we had what proportion of males have shoe sizes greater than 7. So that's going to be all of this part except for that bottom 2.5%. So that's 97.5. Between 7 and 8.5. If you labeled that correctly, that's here. That's that 13.5. The next one, between 10 and 13. So that's from here, from the mean up to 13, two standard deviations above. So that's that 34 plus 13.5. And there's how you get that answer there. And then 8.5 to 13. So that's from here. So I add that 68% up to a size 13. So 68 plus 13.5. And there's how you get your 81.5. All right. Next, we are going to talk about two different kinds of fruit. So this is going to kind of bridge us into tomorrow's or into the next lesson. Here we're going to literally be talking about gala apples and navel oranges. So if you see this abbreviation that looks like this, okay, then that's telling us that the apples are distributed normally. So they follow the normal model and they are centered at 6 ounces and they have a standard deviation of 1. And then likewise for the oranges, They're normally distributed with a mean of 7.5 and a standard deviation of 1.5. So then we come here and we take a look then at how many standard deviations above the mean would a, or below, above or below, would an apple that weighs 5 ounces? Well, first of all, I can tell it's below the mean, and it's 1, so because the mean is at 6, and so it is 1 standard deviation below the mean, okay, because I want to see how far is it away in terms of that standard deviation. And then we do the same thing with the navel oranges. How far away is a navel orange that weighs 10.5? Well, let me see how far away. 10.5 is away from the mean is a total of 3. But the distance of 3 divided by 1.5 is 2 standard deviations. So this 2 standard deviations above the mean. And you can kind of see that down here when we drew out the picture. Now look here, this is interesting. Which is larger compared to the other fruits of its type? A gala apple that weighs 9 ounces, or a navel orange, which weighs 10.5 ounces. And I told you to think about your answer in terms of how many standard deviations they are away from the average fruit of their type. So that's what I did. So a gala apple being 9 ounces is 3 standard deviations above the mean, because the mean for the gala apple was 6. Okay, so the gala apples of 9 ounces is 3 standard deviations above, and the navel orange, we had done that here, is 2 standard deviations above the mean. So relatively speaking, the 9-ounce gala apple is more remarkable, more unusual to find, because it's more standard deviations above the mean than that 10.5-ounce navel orange. And so here is another kind of discussion of, we could draw out these values for the apples and for the oranges. And so we did. And then you could see here on this case, when we do that, you can see then that apple here at 9 ounces, and then versus the navel orange at 10.5 ounces. See, so we can see that that gala apple, like in the problem above, the 9-ounce one was higher up on its curve than the navel orange. But this question asked about shading in 6 to 8 ounces on the apples, and then 7.5 to 10.5 ounces on the oranges. Well, I can tell those are the same sized area. So that tells me that the probabilities of those events is gonna be the same. Okay, they would have the same size area, so they're gonna have the same probability. I could compute that if I wanted to. It didn't ask me to, but there you go. They would be the same. All right, that takes us through the base normal model basics assignment. I hope that you understood that and did well.